An oven circuit that repeatedly burns out can be a frustrating issue. Based on the voltage measurements, several potential causes should be investigated. Firstly, neutral miswiring is a prime suspect. The reported 70 volts measurement between the hot and neutral conductors, significantly lower than the expected 120 volts, suggests a problem with the neutral connection. A staple piercing the neutral wire, as suspected, could create a point of high resistance. This elevated resistance impedes current flow, causing a voltage drop at the oven. Secondly, loose or corroded connections within the junction boxes along the circuit's path can also introduce unwanted resistance. To examine the integrity of the neutral, use a multimeter to perform a continuity test. Measure the resistance of the neutral wire from the overcurrent protection device, such as a circuit breaker, to the oven's connection point. High resistance readings indicate a compromised neutral conductor. Visually inspect all junction boxes for loose or improperly made connections. Ensure all wire terminations are secure and free from corrosion. Moving on, an overload condition could also trigger these symptoms. If the oven is drawing excessive current, it can cause a voltage drop and potentially trip the overcurrent device. To assess this, disconnect the oven and use an ammeter to measure its current draw during operation. Compare the measured current to the oven's nameplate rating. If the current draw exceeds the rating, the oven itself may have a fault. Additionally, a ground fault condition can lead to voltage imbalances. A ground fault occurs when a hot wire comes into contact with a grounded surface. This can divert current away from the intended path, causing a voltage drop on the neutral conductor. Use a multimeter to check for any unintended voltage between the neutral and ground conductors at various points in the circuit. A significant voltage reading indicates a ground fault. The size of the conductor itself may be the culprit. If the existing 10/3 cable is undersized for the oven's current demands, it can lead to overheating and voltage drop, even without any specific fault. Refer to the National Electrical Code (NEC) Table 310.15b16 to determine the appropriate wire size for the circuit's amperage. For example, a 10 American wire gauge AUG copper conductor, depending on the insulation type and termination temperature rating, is typically rated for 30 amps. If the oven's amperage exceeds this, an upgrade to a larger wire gauge, such as 8 American wire gauge AUG, may be necessary. As part of a systematic troubleshooting process, follow these steps. 1. Verify neutral wire continuity. Use a multimeter to test the continuity of the neutral wire from the overcurrent device to the oven unit. Look for high resistance or open circuits. 2. Check junction boxes. Inspect all junction boxes on the circuit for loose or incorrect connections. Tighten any loose connections and ensure wires are properly terminated. 3. Test oven unit. Disconnect the oven unit and test its resistance and amperage draw. If it shows abnormal values, it may be faulty and require repair or replacement. 4. Check grounding. Verify that the grounding system is properly installed and that there are no ground faults. 5. Examine circuit breaker. Test the circuit breaker to ensure it is not damaged or faulty and that it is tripping at the appropriate amperage. If the breaker trips at a lower current than it is rated for, it may need to be replaced. 6. Consider upgrading wire. If all other troubleshooting steps fail, consider upgrading the 10/3 wire to a larger size, such as 8/3, to handle the current demand of the oven unit more effectively. Specifically, to test for a compromised neutral, set your multimeter to measure resistance in ohms. Disconnect the power at the overcurrent protection device to ensure safety. Place one probe of the multimeter on the neutral terminal at the overcurrent protection device and the other probe on the neutral terminal at the oven's connection point. A low resistance reading, close to 0 ohms, indicates good continuity. A high resistance reading suggests a break or significant corrosion in the neutral wire. When inspecting junction boxes, carefully examine the wire connections. Look for loose wire nuts, corroded terminals, or damaged insulation. Tighten any loose connections and replace any damaged components. If using wire nuts, ensure they are properly sized for the number and gauge of wires being connected. A common mistake is using too small of a wire nut, which can lead to loose connections. When testing the oven itself, begin by disconnecting it from the circuit to prevent any accidental shocks. Use a multimeter to measure the resistance between the oven's terminals. Refer to the oven service manual for the expected resistance values. A significantly lower resistance reading than specified could indicate a short circuit within the oven. Next, use an ammeter to measure the oven's current draw during operation. Turn the oven on and set it to a typical baking temperature. Clamp the ammeter around one of the hot wires feeding the oven. Compare the measured current to the oven's nameplate rating. A higher current draw suggests an overload condition. For ground fault testing, disconnect the power at the overcurrent protection device. Set your multimeter to measure alternating current AC voltage. Place one probe on the neutral terminal and the other probe on a known good ground, such as a metal water pipe. A voltage reading close to 0 volts indicates a healthy grounding system. A significant voltage reading suggests a ground fault. Check the circuit breaker to ensure it is functioning correctly. A faulty breaker may trip prematurely, even if the oven is not drawing excessive current. Use a circuit breaker tester to verify that the breaker trips at its rated amperage. If the breaker trips at a lower current than it is rated for, it may need to be replaced. Also, visually inspect the breaker for any signs of damage such as cracks or discoloration. Upgrading the wire size is a more involved process, but it may be necessary if the existing wiring is inadequate. Consult the NEC Table 310.15b16 to determine the appropriate wire size for the circuit's amperage and length. Remember to factor in any dirting factors such as ambient temperature or conduit fill. When upgrading the wire, be sure to use the correct type of wire for the application. For oven circuits, THHN or THWN conductors are commonly used. Also, ensure that the new wire is properly terminated at the overcurrent protection device and the oven's connection point. Before undertaking any electrical work, always disconnect the power at the overcurrent protection device. Use a voltage tester to verify that the circuit is de-energized before touching any wires. If you are not comfortable working with electricity, it is best to consult a qualified electrician. Electrical work can be dangerous if not performed correctly. Incorrect wiring can lead to shocks, fires, and other hazards. When working with electrical panels, be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can cause serious burns and injuries. Wear appropriate personal protective equipment, PPE, such as safety glasses, gloves, and arc-rated clothing. Follow all safety precautions and procedures. Double-check your work to ensure that all connections are tight and secure. Use a torque wrench to tighten connections to the manufacturer's specifications. This will help prevent loose connections, which can lead to overheating and fires. After completing the electrical work, test the circuit to ensure that it is functioning correctly. Use a multimeter to measure the voltage and current. Also check for any ground faults. If everything checks out, you can restore power to the circuit. In summary, diagnosing voltage drop issues in an oven circuit requires a systematic approach. By carefully examining the neutral wiring, checking for overloads and ground faults, and verifying the wire size, you can identify the root cause of the problem and restore the oven to proper operation. Remember to always prioritize safety when working with electricity. If you are not comfortable performing the work yourself, consult a qualified electrician. Furthermore, to elaborate on neutral wire issues, consider that a neutral wire carries the unbalanced current back to the source. If the neutral connection is compromised, this return path is restricted, causing the voltage to shift. A properly functioning 240-volt circuit, like that for an oven, relies on two 120-volt legs that are 180 degrees out of phase. When measured between the two hot legs, the voltage should be approximately 240 volts. Each hot leg should measure approximately 120 volts to neutral. The fact that one leg measures 70 volts to neutral suggests an imbalance. This can occur if the neutral is broken or has high resistance, causing the voltage to redistribute unevenly. To confirm the integrity of the neutral, perform a voltage drop test under load. With the oven turned on, measure the voltage between the neutral terminal at the overcurrent protection device and the neutral terminal at the oven's connection point. A significant voltage drop indicates a problem with the neutral conductor. The voltage drop should be minimal, ideally less than 2 volts. The presence of a voltage drop indicates resistance in the neutral wire, which is impeding current flow. To further investigate the neutral, visually inspect the entire length of the neutral wire for any signs of damage. Look for nicks, cuts, or corrosion. Pay particular attention to areas where the wire may have been stapled or subjected to physical stress. Remove any staples that are piercing the wire and repair any damaged insulation. Consider using a wire tracer to trace the path of the neutral wire and identify any hidden junction boxes or splices. These hidden connections can be a source of problems. If you suspect a loose connection within a junction box, carefully disassemble the connection and inspect the wires for corrosion or damage. Clean the wires with a wire brush and apply a small amount of antioxidant compound before reassembling the connection. Ensure that the wire nuts are properly sized and tightened. Over-tightening wire nuts can damage the wires, while under-tightening can lead to loose connections. Use a torque wrench to tighten the wire nuts to the manufacturer's specifications. If you are using push-in connectors instead of wire nuts, make sure that the wires are fully inserted and securely locked in place. Push-in connectors can be convenient, but they are not as reliable as wire nuts. Consider replacing push-in connectors with wire nuts for added security. When working with aluminum wiring, use special connectors and antioxidant compound to prevent corrosion. Aluminum wiring is more susceptible to corrosion than copper wiring. Follow the manufacturer's instructions when working with aluminum wiring. In addition to checking the neutral, it is also important to verify the integrity of the ground wire. The ground wire provides a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electrical shocks. Use a multimeter to measure the resistance between the ground terminal at the overcurrent protection device and the ground terminal at the oven's connection point. The resistance should be very low, ideally less than 1 ohm. A high resistance indicates a problem with the grounding system. Inspect the ground wire for any signs of damage or corrosion. Make sure that the ground wire is properly connected to all metal parts of the oven and the electrical system. If you suspect a problem with the grounding electrode system, consult a qualified electrician. The grounding electrode system is a critical safety component of the electrical system. It provides a low impedance path to ground for fault current. A properly installed grounding electrode system can help to prevent electrical shocks and fires. To further elaborate on overload conditions, consider that an oven can draw a significant amount of current, especially during the preheating cycle. If the oven is drawing more current than the circuit is rated for, it can cause the overcurrent protection device to trip. Check the oven's nameplate for its amperage rating. The amperage rating is the maximum amount of current that the oven is designed to draw. Compare the oven's amperage rating to the circuit's amperage rating. The circuit's amperage rating is determined by the size of the overcurrent protection device. If the oven's amperage rating is higher than the circuit's amperage rating, the circuit is overloaded. To correct an overload condition, you can either reduce the oven's current draw or increase the circuit's amperage rating. To reduce the oven's current draw, you can try using the oven at a lower temperature or for a shorter period of time. You can also try using a different oven. To increase the circuit's amperage rating, you can replace the overcurrent protection device with a larger one. However, you must also upgrade the wiring to match the new amperage rating. Consult the NEC Table 310.15b16 to determine the appropriate wire size for the new amperage rating. Remember that the overcurrent protection device is designed to protect the wiring from overheating. Do not replace the overcurrent protection device with a larger one without upgrading the wiring. This can create a fire hazard. Finally, to elaborate on ground fault conditions, consider that a ground fault occurs when a hot wire comes into contact with a grounded surface. This can create a dangerous electrical shock hazard. A ground fault can also cause the overcurrent protection device to trip. To check for a ground fault, use a multimeter to measure the voltage between a hot wire and a grounded surface. The voltage should be very low, ideally less than 1 volt. A high voltage indicates a ground fault. If you suspect a ground fault, disconnect the power to the circuit and inspect the wiring for any signs of damage. Look for nicks, cuts, or corrosion. Pay particular attention to areas where the wiring may have been subjected to physical stress. If you find any damaged wiring, replace it with new wiring. Also, check the grounding electrode system to make sure that it is properly installed and functioning correctly. A faulty grounding electrode system can allow ground faults to persist. If you are not comfortable working with electricity, consult a qualified electrician.